Welcome to Conversations Under Insulation. It is Conversations Under Insulations. It's for CUI focused panel session. And today I'm very happy to welcome our guest, Philip Enegela from INEOS. And he's an expert on asset integrity and very vocal advocate of best practices in CUI. Hi, Philip. Welcome.
Thank you very much, Prafull, and thanks for this opportunity to speak on a topic that I think is dear to both of us and to many others in industry.
Exactly. Thanks, Philip. We would like to understand from you, Philip, you come from petrochemicals industry and have been a very vocal advocate about mitigations of CUI. So let's understand first, is it really true that petrochemical industry is suffering from CUI in the UK and elsewhere in the world? And why?
So yes, it is true that we have lots of CUI incidents and failures in the petrochemical industry, but it cuts across many other industries globally. And this is an issue that manifests really wherever you've got insulation. So irrespective of the type of insulation that you have, you will find corrosion under it. It proceeds faster or slower depending on the temperature and lots of other factors. So it's not peculiar to the petrochemical industry, but some of the decisions that were made in making the equipment or manufacturing the plants, the design of the plants were perhaps a bit inimical, if we want to look in hindsight, to the issues that we currently experience in terms of CUI. So having a lot of insulation for heat conservation, for personal protection, because we have a lot of people on our sites in petrochemicals, is one of the issues that has precipitated a lot of CUI failures in the past. And this is why we need to manage it better.
I guess one of the probably reasons is petrochemicals is invariably located close to the ocean, maybe, or sea, close to the coast, because of the feed coming in and exports. Do you think that's one of the reasons of high CUI rates?
That's absolutely right, because the environment plays a big part in it. So for CUI to occur, which is basically an accelerated form of external corrosion, albeit under insulation, you need the material, either bog standard carbon steel or stainless steel, low alloy steel, to be affected by the effects of the environment and have that electrochemical degradation process. So that's a bit of technical jargon there. The location is quite key, because where we have our industries, we tend to create an industrial atmosphere where we have a lot of pollutants, contaminants, and then, as you've mentioned, we have the location quite close to the sea to enable the transport of feedstock and finished products away from the site as well. So we then tend to have a mixed atmosphere, which is a sort of cross between a marine atmosphere and an industrial atmosphere, and that is a recipe for rapid CUI to occur.
And is it a global problem? Is it a global petrochemical industry or a specific geography you see?
Well, again, you will have differences in the environment in certain areas. So in the UK, we have quite a lot of precipitation or rainfall, and that affects to a great extent how much CUI we see. So in other geographies, you may not have as much rainfall, and that can contribute, or that can positively affect it. Nonetheless, we have to design the mitigation measures to make sure that we prevent water from getting in. So once you have water in the system, and that can be from the environment or from the process itself, you then start to get a lot of corrosion. So the environment can play a part in it.
I guess you're referring to not only the rainwater, but also process temperatures, which means sweating service or intermittent operations, right?
Precisely.
And that's why I think, from a lot of people I talk to, experts I talk to in even Middle East, there's an issue on CUI. There's a rain is less, but the sweating service of below dew point, pipelines or assets, they are suffering from CUI. So I think it's a global problem, as you said, maybe due to weather or maybe due to type of processes. So as far as petrochemicals is concerned, is it a main problem in hot type of insulation or a cold type of insulation, or both?
I would say both, but what you find is because we operate equipment within the CUI range, and by the CUI range here, you want to think of 0 and above. So where you have water as a stable phase, then you can have a lot of CUI happening. Now, the probability of CUI progressing faster will increase with increase in temperature up to a certain extent until the water is fully evaporated from the insulation system. Nonetheless, in cold systems as well, where we have breakdowns in the vapor barrier and the insulation system, we start to attract moisture in, or we can have ice formation. And once we have that, then we can have CUI occurring, but the kinetics or the speed at which it occurs may be a bit slower. So irrespective of the insulation type, you will get some corrosion, but we tend to find that it's a bit more rapid on what we tend to term as hot insulation applied to processes above 10 degrees to around about 175 degrees, what we tend to term the CUI range, if you like.
And this is this applicable to pipelines majorly, or even equipments like pressure vessels and other type of equipments?
It is indeed applicable to both. So you will get CUI occurring on pressure equipment, so pressurized equipment such as vessels, reactors, etc. On pipelines, on piping, you will get that happening. But there is an interesting split between the amount of CUI that you tend to see on fixed equipment compared to when we look at our pipe work. So there's about an 80-20 split. So most of the CUI, around 80% of the failures or effects we will find on pipe work, and then around 20% on other equipment such as the fixed equipment that we see. So taking care of pipe work is actually quite important.
And when it comes to equipment, is it what type of equipments we are talking about? Is it heat exchangers or columns or tanks? Or
so again, a vast array of fixed equipment. So you can talk about heat exchangers, you can talk about storage tanks, we've got reactors, we've got towers, lots of different equipment. So if you've got it insulated, there is every chance that you will find CUI at a susceptible location.
so what are the typical susceptible locations? Say, let's talk about say pipelines. Let's talk about small diameter pipelines, say less than 4-inch. What are the typical locations? And then we'll talk about the larger diameters.
So that's a good question. If you imagine that you've got a horizontal line and you've mentioned nominal bore of 4-inch or less, what you find on that is if it's a long length, we will then need to provide supports for that. And that is to keep it mechanically sound and to bear the stresses. The issue with doing that is the type of support that we will have on it is a contributor to the kind of CUI that we find. Okay, so if we've got a support that's welded on, then we will find that at the 6 o'clock position or the bottom of the line, we will find that water will pool. Those areas are quite difficult to get to and paint or to dress out and profile, and that starts to be the location where we get a lot of wall loss through CUI. If you've got a U-bolt type system on that pipe, then you will get corrosion that will happen all around that U-bolt because that's the entry point. So the extent of CUI that you see may vary. It could be at the bottom of the line or the pipe, or it could be beside it because that's the entry point. But something to keep in mind is that we need to keep the water out of that piping system, and the insulation is part of the piping system as has been designed.
And what is the way of keeping the water out? What are the best practices?
So we need to build barriers. So when you have an insulation system, the first thing you need to look at is what's on the outside. So on the outside, we have a cladding system, typically or traditionally, it will be metallic, either stainless steel or you will have aluminum. Now, they're all joined up with tiny little joints where we can apply something called mastic. When we apply the mastic, we need to make sure that it stays in place and it's very generously applied. Now, a breach of that mastic will be an ingress point into the insulation system. Okay, so we've got to take care of that first of all when we are installing the system, and we make sure that it's properly sealed. So that's why we require quality checks to be done through QC practices. The next bit is we need to specify the right type of insulation, and the insulation that we put on should be able to, depending on its functionality, reject the water. That is, it should be hydrophobic. So with increasing hydrophobicity, you will then get water being repelled out of the system, and it can probably drain out if you've got drain ports that have been built into your insulation system. And the third is we can put a barrier in place, namely a coating. So this can be an organic coating, or it can be a metallic coating or a cladding. If we do put all of these systems in place and put the barriers in place, have the right checks, then we'll keep the water out and we will mitigate, or if we're lucky enough, prevent CUI from occurring.
So that's great. I think the best case scenario is no CUI. But
Indeed.
But even if there's no CUI, the uncertainty around not knowing being foolproof system is not good, right? That we still have to inspect if we don't have trust in the systems we have put together. So that's something which is a issue. So you talked about pipelines, small pipe diameters, 4-inch or less, and then the best practices around hydrophobic insulations, coatings, and sealings. What about the large pipe diameters? Is this similar situation in the large pipe diameters, like probably 12-inch or higher?
So yes, the same principles apply here. You need to keep the water out of the system, and you need to have the barrier systems working properly. The other thing is, as you increase the size of the line, the chances you can increase the thickness of the piping. So that is something, another parameter that has a significant impact on whether we have a failure via CUI or a loss of containment event. So building or adding on a corrosion allowance and having a higher tolerance will then make sure that we have enough material for pressure containment. So that is something else that we can achieve with higher schedule or bigger piping, if we want to look at it that way.
Okay, so it's similar, but we talked about pipings and we talked about large and small diameters, but normally they're hot. Now, if there's a cold cryogenic pipelines or sweating service pipelines, is the problem the same, or there are different locations of the problems or the nature of problem?
So the susceptible areas may be the same, and if you then have a change in the process, or the process temperature then starts to change from, let's say, around about 10 degrees to -10, then you can get a lot of sweating happening. So where you did not have any moisture coming into the system, you can then get some moisture being created by the process in itself. Okay, so what we tend to refer to as sweating service is really manifest when we see or remove that insulation to have a look under, and we see that the process now makes water sort of form on the piping. So again, it has to do with pooling of the water. So where are the areas that this water is going to pool? What sort of degradation rates can we expect there? And of course, what sort of failure would we then experience? So sweating service is slightly different from where we have external water ingress, or where we have some other factors like deluge contributing to the water entering the system. But ultimately, the form of degradation and the manifestation of that degradation is the same.
Okay, so even for sweating service is the same. Now let's talk about equipments. So starting with hot equipments, very high columns maybe. So where do you find CUI normally in such equipments?
So For those sorts of equipment, you can find it at support rings. So we tend to put our insulation on insulation support rings. We can have vacuum support rings as well. We have trunnion supports. We have lots of nozzles coming out of these because in trying to design the towers, we want to extract different products at different levels. Okay, so these are examples of locations where we can find CUI. Coming down to the sort of skirt level as well, we might have the insulation terminated poorly, and that can be an ingress point. So we can get a CUI occurring around that area. And we can get a different form of corrosion under fireproofing, if you want to call it. So it's akin to CUI, but this time it's under fireproofing, and this tends to occur where we have passive fire protection. So CUF is also another issue that we have to contend with.
So what I understood is, on the columns, support rings, as well as difficult geometries like protrusions or nozzles, they are very prone because they are entry point of water and humidity. And then you mentioned about CUF, which is corrosion of fireproofing, which is on the skirts, which are very prone to, which is a kind of variant of CUI, we can say, but a CUF. But columns are suffering from CUI. But are there cryogenic assets, vessels, which are also suffering from CUI? Do you see examples of that, or they are too low a temperature for CUI?
So again, what we've got to think about is the effect of temperature on CUI. So at low temperatures, the rate will reduce, but it doesn't mean that it's not happening. And this is very, very visible on piping. So if you've ever seen what we refer to as the cold side of any petrochemical plant, you will see that there's a lot of ice formation and there's a lot of moss growth. So why does the moss grow? Because sometimes the ice melts and then we get moisture, and that sustains the life there. Okay, so you might get certain layers of water that exists or that exist in equilibrium with the ice. You can also get situations whereby the plant is actually flat and there's nothing contained there, so the entire pipework warms up and you get a lot of the ice actually melting. So lots of water falling off of that of the structure. You get cascading water as well. So in a case where you've had a deluge system being operated, you can melt some ice and that can result in water ingress somewhere else. So for cold items, it doesn't mean that we don't get CUI. It is slower, perhaps more imperceptible, and perhaps more difficult to then anticipate.
Thanks. And what I keep hearing is about, there are assets which are intermittent operations, cold to hot or maybe hot to hot, but they're different varying temperatures. Are there examples of that? And is CUI a problem? What are the equipments which are prone to such situations?
So we've got a lot of equipment that are prone to such cyclic conditions. That's what we tend to refer that as. And we've got dryers, for example, dehydrators. So we might cycle the equipment every 6 hours. So it may operate in one phase at 230 degrees. And then in the next phase, it may operate at 12 degrees. So when you're in absorption mode, the temperature is very different from when you're in regeneration mode. And when we have that alternate wetting and drying, alternate accumulation of salts will happen. So in a case where it's a stainless steel material, when we drive off the water, we can concentrate up the salts. And in the next cycle, we make the solution perhaps more corrosive. So in doing this, this affects the rate of degradation. So having it wet all the time may turn out to be better than having it through the number of cycles that we can see, because some items can be regenerated in every 6 hours, every 2 hours, every 24 hours, depending on the required frequency.
To summarize, we talked about petrochemical industry global. There's a problem not only in the UK and environmental factors, but also in probably desert and Middle East and low rain environments. It's a problem in pipelines as well as equipments, as you said, and also cold, hot assets, and also cold assets, but cold assets less corrosion rates. I think one of the problems we had is because many times petrochemical industries or plants are located close to the sea, the corrosive environments are higher because of that. Um, and also, it's not just the pipelines or pipes, it's also about equipments which are facing the problems. Although you divided 80-20, 80% volume is in the pipelines of CUI issues and probably 20% in the equipments, if I got it right. Large diameter, small pipe diameter, the protrusions are the main problems. But also on equipments, you said it's the columns which are having support rings and the nozzles which are specific issues, and also this is not just CUI, even CUF is an issue on the skirts. So a lot of interesting insights, and then we talked about intermittent operations and cyclical operations, as you say, for example, dryers and dehydrators and petrochemicals, which operate in a cyclical mode, and there are many such assets which are very prone to CUI. So with that summary, thanks, Philip, for a lot of insights. I think the next episode, we will talk about some of the mitigations and the best practices to manage the CUI. Till then, thank you, Philip. See you in the next episode.
Thank you very much for having me, Prafull, and it was exciting to talk to you about this topic.